In this video, we'll introduce and demonstrate advanced routing on cloud load balancing within the Google Cloud Platform. Let's very quickly create a diagram for what we're going to demonstrate in this video, and then we'll jump into the Google Cloud Console to set up these resources. We'll also share the configuration as code in the description of this video through a GitHub repository. With this code, you can copy and paste and then play with these configurations yourself. While we'll touch a couple different services, we'll spend most of our time with the Cloud Load Balancing service. There are a variety of HTTP request parameters that we might want to use for routing or rewriting. These could be things like hosts, URIs, and headers. A few of these options will be explored in the demonstrated examples. We're going to have a great foundation for testing these load balancer configurations by leveraging the HTTPS Echo project running on Cloud Run. The Cloud Run services provide a simple and low-cost way to debug and play with our load balancer configurations. Using cloud load balancing and serverless network endpoint groups, we'll be able to showcase the configurability of GCP's cloud-native load balancers. Specifically, we'll focus on the advanced routing capabilities of cloud load balancing. With what we're trying to achieve now established, let's jump into the Google Cloud Console and set up these resources. The first thing we need to do is set up the Cloud Run services. Let's click Create Service. And again, we're going to use the HTTPS Echo project as the backend application. This will echo back a lot of HTTP request parameters in the HTTP response. The code for this project is open source, and the description of this video contains a GitHub link. We want to allow unauthenticated invocations for our testing and also define a couple environment variables. Specifically, we want to explicitly tell this application where to serve HTTP and HTTPS requests. We could potentially change the memory and CPU configuration, but for our demonstration, the defaults should be fine. Let's click Create. And we can create two other similar resources for our other two Cloud Run backends. So this first service that we created will act as a sort of default or baseline for us. Meanwhile, Service 1 and Service 2 will be used to showcase different routing and rewrite policies. All right. Our services are now being created. Let's now go to the load balancing to set up our load balancer. We're going to do HTTPS as the protocol for this load balancer, and we'll use Google's managed SSL certificates to make that quite easy to configure and manage. We'll use the newer version of the global HTTPS load balancer. And start to fill out the configuration here. In order to use an HTTP to HTTPS redirect, we need a static IP. To get that, we can create an IP address here and give it a name. Once that static IP is created, we can enable this HTTP to HTTPS redirect and create a new certificate. We just need to provide a domain for the certificate. With this certificate approach, we'll need to create an A record for this domain in our DNS system. That way, Google can do the HTTP ACME challenge and provision the SSL certificate for HTTPS traffic. The backend configuration is where it starts to get interesting. So before we talk about and set up that, let's take care of our DNS record. I actually have the DNS zone for this domain in a different project, so I'm going to switch to that and then set up the record. Alright, so we'll set up that domain name and public IP here. Now, in theory, you could test a lot of the advanced routing capabilities without HTTPS and without the HTTPS redirect. However, while it's optional as you follow along, we'll go the extra mile here to showcase a more production-like scenario in Google Managed SSL certificate concepts. This is actually one of the advantages of this managed load balancing. We can stop worrying about the provisioning and management of certificates. Anyway, with that record now in place, our certificate will eventually be able to provision. We'll let that run as we walk through the backend and routing rules configuration. So, in our backend configuration, we're going to start with our default baseline backend. We'll choose serverless network endpoint group, which will allow us to hit Cloud Run services. Make sure you select the region where you ran those Cloud Run services. I ran them in the default region for me, which is US Central 1. Next, we'll select our baseline service here. We do not want Cloud CDN in our demonstration, as the resultant caching could complicate our experimentation. Okay, let's create that backend service. While we're here, let's create the other two backend services as well. All right, so we've created three separate backends for our three Cloud Run services and can now use them in load balancer experimentation. Next up, we have the routing rules. By default, it's going to give us the interface for simple host and path rules. However, this is an advanced routing introduction, so let's select that. If you're routing by host, you're going to use a couple of these configuration blocks. For each configuration block, just set the hosts to match your desired policy. We're going to simplify things a bit and use a single host, so we'll just need one of these specifications. I'm going to paste in some code here so that we can see how these rules are built out. This will showcase a few different cases, and we'll talk about and demonstrate each one. The core of this configuration is the route rules, which effectively tells us where to send traffic and under what circumstances. We can potentially modify that traffic as well. So let's walk through each one of these. The first example redirects the URI of /redirect to example.com. It's going to strip our query parameters when we do that redirect. With a priority of 0, this routing rule cannot be overruled by other routing rules. When routing traffic, the load balancer checks all the rules and will send traffic to the default backend if nothing matches. In the next example, we have a prefix match for the path. We could match on the URI exactly or as a prefix. However, regex-based routing is only possible on internal HTTPS load balancers. In general, load balancer capabilities can change depending on the type of load balancer. Anyway, for our external HTTPS load balancer, we're showing a pretty simple prefix match here, and then sending to a backend. We're going to send to our backend 1, and just so that the backend is clear in our HTTP responses, we're going to do this host rewrite. We'll see in a moment when we demonstrate these rules why this host rewrite is helpful. In the next rule, we have a pretty similar case, but with a different prefix match so that we can compare and contrast with the previous routing rule. We're sending this routing to a different backend to make the routing behavior clear. Next, we have some URI path rewriting. So, for example, imagine we have a subfolder that we want to remove before we pass the request onto a backend. We're covering that case here. The slash subfolder will be replaced by just a slash. Users will not see this as it's just propagated to the backend rather than, for example, being implemented as a redirect. When this is propagated to the backend service, we'll serve the request from that service one. Again, we'll do a URL rewrite to make the backend obvious when we see the HTTP response. In the next and final case, we have a query parameter match. So when we see this user query parameter present, we're going to map to this backend. As with URIs, there are different ways to match on query parameters, but regex matching is only available on a subset of the load balancers. Now that we've talked through these rules and how to construct these YAML configurations, let's point out some important reference documentation. This URL maps REST resource is a page that I go back to regularly, and it's really helpful for understanding what capabilities are available in each one of the load balancers. Fields are accompanied with nice descriptions. For example, let's search for query parameter matching. We'll see further down how we can specify a query parameter matching setup. So the configuration requires a name, and we have that provided here. That's the name of the query parameter. We can either have present match, exact match, or regex match. Present is what we're using in the example, so if there's a user query parameter provided, regardless of the query parameter's value, we're going to follow that routing. Great, so let's apply and test some of these configurations. And as we see from this error here, we are missing a field in the configuration. That's pretty clearly highlighted in the user interface here, so we just need to select a backend for our default configuration block. This is needed because we've specified a host here. In theory, we could also be using this load balancer for an IP or a different domain, and this fallback service would be served in those cases. So we'll just do our base service there, and that should resolve all the issues. It looks like our service has now been created, so let's check on the provisioning of that SSL certificate. It looks like this is still provisioning, so we'll have to wait another minute or two. We often see this provisioning take up to 10 or 15 minutes. However, if you start the certificate provisioning significantly before setting up the DNS-A record, then completing the HTTP ACME challenge could take significantly longer. Now it looks like that certificate has been successfully provisioned. So we should now be able to demonstrate our load balancer. Let's bring up the configuration again, just so that we can follow it as we test. We'll start with this first case. If we go to /redirect, we should be redirected to example.com. It looks like Safari is still picking up that SSL certificate, so we'll give it just another moment. All right, and there's our response. This is why the HTTPS Echo project is really helpful. It shows us a lot of properties about our request. If we navigate to the root directory, we're going to see that we're served from the base Cloud Run service. However, we can demonstrate the first rule by going to /redirect, and it will bring us to example.com. Let's demonstrate the other cases, which, again, you can play with by copying and pasting from the GitHub repository. If we go to /1, we should hit backend1, and if we go to /2, we should hit backend2. Next, we have this path rewrite for /subfolder. So if I go to /subfolder/foo, then our backend only actually sees /foo. The subfolder from our original request is rewritten before it hits the backend. Finally, let's add a query parameter to our request, which should route us to backend 2. So if I go back to the root, we're going to hit the default backend here. However, if I provide the user query parameter, then we start to hit that service 2. We can even see the query parameters displayed down here. So hopefully this has been a helpful introduction to advanced routing rules. In addition to the documentation around the URL maps, this code guidance modal is quite helpful. This walks you through a number of very interesting use cases and shows you how to write associated YAML configurations. Just keep in mind, as I alluded to earlier, that the different load balancers have different capabilities. So, for example, if we open up the header-based traffic steering example, we'll see regex matching configuration that won't actually work on our external HTTPS load balancer. In any case, these examples can give you a good idea of the art of the possible and provide some foundational configurations to play around with. Let's wrap up by talking about the costs here. You're almost certainly going to be at the free tier for Cloud Run. So we'll leave all those costs at 0. This is true even with 3 separate services, unless you're pushing really heavy traffic or using high resource allocations. Further, even beyond the free tier, these services have a minimum instant count of 0. So the billing follows actual usage, and low traffic sites may run for many hours of the week at negligible cost. For more complex production scenarios, you'll have to use Google Cloud's pricing calculator to model what the costs are going to look like for your particular scenario. In any case, the cloud load balancing does have some significant cost. For just a few forwarding roles, like we've set up together, will be at $18 per month. The other cost that we need to account for here is the static IP. So when we provision a static IP, like we did earlier, we'll be charged $3 per month. Looking at the total cost, we're at $21 per month for this setup. With that in mind, if you don't need them long term, be sure to delete the load balancing resources. We can do that very quickly together in the Cloud Console. When we go to load balancing, we'll have both the HTTP redirect and HTTPS load balancer to delete. When it asks us if we want to delete the backend services and the SSL certificates, select all of these resources. We'll also need to delete the Cloud Run services. And finally, we created a couple auxiliary resources earlier and need to delete them. First, delete any IPs. Next, we want to remove our network endpoint groups. These resources are actually separate from the load balancer, even though we created them through the load balancer creation interface. That interface was really just a shortcut for creating the resources, and their lack of strict connection to the load balancer means they need a separate deletion step. The last step is to clean up any DNS records. Again, in my case, the DNS is in a different project. So I'll switch to that now and delete the relevant records. We now have a clean slate, just like when we started. Since the costs outlined earlier are not charged in monthly increments, but rather via pay as you go, our demo cost will be nowhere near the $21 mark. Hopefully, this introduction to advanced routing within cloud load balancing has been helpful. We recommend checking out the various links in the description of this video and want to thank you for watching.